Assalamu alaikum students. In this video, I'm going to explain the concept of power generated by the generator, power delivered to the appliances, and power consumption across the resistance of the wires due to their material or internal due to their material resistance. So in this question, the diagram shows an electric pump of the garden fountain connected to an 18-meter long cable. The cable is 18-meter long, and it consists of 230-volt mains electric power supply. These are your main electric power supply input voltages, and the 18-meter long wire one sided and 18-meter long wire on the other side is available, and this is going to deliver the power supply to the pump. The performance of the pump is acceptable if the potential difference across is at least 218 volt. Output of the wire was 218 volts. Okay, so for this 218 volts, it means that out of 230, 218 is at the end. It means 12 volts are dropped across these two wires. And if I say that 6 volts are across this one and 6 volts are across this one, so when I consider this all, that what is the maximum resistance per unit length of the wire? So current is given to you. This is 0.83 ampere. What is the maximum resistance per meter of each of the two wires? This is very important, that we have to find out the resistance of the wire in each cable of the pump that is performing the acceptable performance. So let's solve this. It's a bit tricky but easy question, not that much hard. Let's make these two wires as two resistors, and then let's make this motor as an output pump, and then I can have another wire, and another, this wire will behave like another resistor rather, and then this is your 230-volt power supply. So here its resistance is R, and the output voltages are over 218 volts, and the current flowing through this is 0.83 ampere. It means this would also have the current of 0.83 ampere, but as I know that out of 12 volts, because the wires are identical, 6 volts are dropped across this one and 6 volts are dropped across this one. So by using very simple technique, I can say that if V is equals to I times R, then R is equals to V divided by I. So V is your 6 volts divided by I is your 0.83. So this gives you 6 divided by 0.83 is equals to 7.2 volts. 7 point 7.2 ampere. This is the total resistance, right? This is the total resistance. My option is, what is the resistance per unit length? Check this one out. What is the resistance per unit length or per meter? So I would consider the length of the wires, which is 18 meter. What is the length of the wires? 18 meter. So I would divide this. The resistance per unit length is equals to 7.2 divided by 18. It is 0.4 ohm per meter. 0.4 ohm per meter. So let's check this one out. So this is having option A. So I hope that this question would be clear to you.